Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Friends, welcome to the 9th lecture on the SwayamPrabha course titled Maritime Structures Under Fire, Blast and Explosion. This is a professional course which helps us to learn more about the important characteristics of this natural as well as artificial disasters caused by fire, blast and explosion, which are inevitable accidents which occur in heavy industrial structures quite often, and we are more concerned about this when they happen to occur on maritime structures, because most of the maritime structures under such accidents remain unmanned and the losses are very severe in terms of its financial as well as economic loss. It also affects the environmental conditions and the adjacent segments of livelihood, etc. So they cannot be allowed to sustain causing damages to maritime structures. Therefore, we are looking them in detail about how to mitigate them, how to suppress them, how to reduce their consequences if they occur. But for sure friends, very difficult to make a explosion proof, blast proof, fire proof structures, because these are quite accidents. They happen because of unfavorable conditions. However, if they occur, we can always intelligently plan to reduce the consequences caused by them, and we also design the structures to sustain them to some time until which evacuation of people can happen. So, more into perspective of safety concern and more in the perspective of reliability concern, these ideas are being discussed. So, welcome to lecture 9 friends, where we are going to talk more in detail about the explosion characteristics. Quite interesting reference for this lecture could be this particular book, which is authored by me and Pradibha. So, try to have a copy of this book and learn more in detail about this as long as we proceed further. So, in continuing with the what we had in the last lecture, we were discussing about the characteristics of industrial fire, let us say with pool fire. Pool fire exhibit distinctive characteristics. The fire burns with visible flames. It radiates heat and of course produces large smoke. If you are delaying the suppression of the system, which causes pool fire, it depends largely on size of the pool and the type of the liquid in the reservoir or in the tank. When the fire is continuous to burn beyond the boundaries and beyond the bunds, then we can identify this as something called running fire. This is when the pool fire continues to burn beyond the bunds. Yesterday we discussed about what is a bund in the last lecture. The burning rate in the pool fire is a primary function of fuel's heat of combustion. And the heat required for its vaporization. The heat radiation typically dominate the burning rate of flames. Of pool fire. This radiation field extends outward from the fire and creates hazard in the adjacent zones. Let us extend this knowledge to learn about jet fire. Jet fire occurs when a flammable liquid or gas is ignited immediately after its release from a pressurized vessel. So, when a pressurized vessel releases gas or flammable liquid and immediately ignited, then you get jet fire. This got a very high pressure at the release end. Jet fire possesses high momentum, therefore it can cause something addressed as directional flame. Okay, that is very important because this keeps on spreading at a considerable distance from the point of source. So, the spread is quite fast. And quite long. It spreads for a longer distance. These fire are characterized by one, the concentrated nature, and two, the kinetic energy involved in release. Jet fires typically form when high pressure systems containing flammable materials develop leakages caused by equipment failure, physical damage, operational errors, and that can result in jet fires. Jet fires are typically long and narrow. Okay? And they have got very high release rate. And they are concentrated in specific direction. The length of the flame directly is related to the flow release rate. The typical pressure release of a jet fire is actually about 8 kgs per second. That is a typical release rate. And the fire can spread as far as 35 meters. Crosswinds, if any, will actually amplify this fire spread for longer flames. Okay? So, what are the sources of fire? Of jet fire? Jet fire can happen when there is a rupture in high pressure gas pipeline, when there is a leak from pressure relief valves, when a pressurized vessel fails at connections or joints, when a compressor pump fails at the pump seal. These kind of fire relates from here. The other one which is very serious industrial fire is flash fire. A flash fire is defined as combustion of flammable vapor and air mixture in which the flame passes through the mixture at subsonic velocity. So, the speed is at subsonic velocity. So, it has got a very negligible overpressure. The fire occurs when a cloud of flammable gas released or dispersed and a flammable mixture with air subsequently encounters ignition source. The key characteristics of this fire is that it has got a pre-mixed fuel. Plus air getting mixed together and they are within the flammable range. That is very dangerous. That is between the lower flammable limit and the upper flammable limit. We will talk about this much in detail in the coming lectures. Now, let us say when a flash fire can occur. A flash fire can occur under the following conditions. 1. When there is a release of a vapor cloud coming out from a flammable material. 2. When this cloud disperses in the atmospheric process. And thirdly, the cloud encounters an ignition source. Okay. So, flash fire will be caused. They travel at a typical speed of about 4 to 5 meters per second. That is the speed with which they travel. Of course, it depends upon the fuel type and concentration, but this is a general speed at which it propagates. The duration of the flash fire is very short. That is one good thing about it. It does not burn for a longer time. It is typically less than 3 seconds. The damage is essentially caused, is primarily caused by thermal radiation in enclosed spaces. Okay. The typical heat flux this fire can produce is about 80 kilowatts per square meter. That is a flux. What are the causes of this kind of fire? It can occur when there is a gas leak from a process equipment, when there is an excessive ventilation or venting of flammable gas, when there is a ventilation of flammable gas which gets dispersed in atmosphere, when there is an evaporation of spilled liquid, vapor cloud is formed and that is the danger. When there is a release of liquefied gas, especially in regasification plants, then they will also form flammable clouds, and that is the reason why this kind of fire are formed. The next one is the fireball. Fireball is actually a spherical mass of flame. Which is resulting from ignition. The causes could be caused by ignition of large rapid release of flammable material. A typical example of this is Blevy. Blevy is boiling liquid vapor expanding vapor cloud. Explosion. Blevy is a very undesirable explosion which occurs when a large quantity of flammable material is released and it comes in contact with the ignition source. Fireballs actually often form, they form due to delayed ignition, high momentum, release of flammable gas. The other reason could be if there is a release from pressurized vessel. Can also result in fireball. There is a key distinction of this kind of fire from other types. There is a key difference of this from others. It carries unburned fuel. Upward the buoyant plume, upward the buoyant plume, and this creates a three-dimensional spread flammable, combustible material. So, this not only grows horizontally, it also grows vertically. So, that is the issue with the fireball. They are very catastrophic. They spread along x, y and z directions. So, it is a three-dimensional spread. So, what are the causes, the reasons why a fireball occurs? The fireball occurs when there is a levy of a pressurized storage vessel. It also occurs when there is a sudden failure, pressurized pipelines, can also occur when there is a delayed ignition of high momentum, large quantity flammable material. Released with pressure. It can also occurs with the rupture of vessels, storage vessels. So, these are the reasons why a fireball can occur and so on. Having said this, let us talk about something on the explosion phenomena. In addition to fire hazards, explosion also poses severe risk. Explosions are categorized or classified as two: as deflagration and detonation. Depends on the speed of the combustion wave. Deflagration involves subsonic flame propagating through unburnt fuel, whereas detonation occurs when the combustion generates a supersonic shock. This causes catastrophic damage to structures. Boiling, liquid, expanding, vapor cloud explosion occurs when a pressurized liquid is or pressurized liquid container is exposed to heat and the vessel ruptures. Vapor cloud explosion which is called as VCE results from ignition of dispersed flammable gas. Which is very common in industrial structures or industrial accidents. So, one can now say high temperature can cause material degradation, we have seen that already, can also cause expansion, strength reduction, and they all lead to potential collapse. Therefore, friends, under such condition, when blast waves or overpressure forces also get applied on structures external forces, then the structural system is completely compromised. So, understanding these effects is essential in fire and blast resistant structures. So, when you look at the consequences of fire and explosion, it is important that the damage caused by material degradation, strength degradation, stiffness degradation at high temperature is added to additional forces caused by fire, explosion and blast. So, the severity is multidimensional because these are added to this, to the existing issues. When we talk about combustion characteristics, the characteristics of fire and explosion depends on the vulnerability of the structure and its effectiveness of protective design strategies. Fire behavior is essentially governed by three critical factors. One, the flame spread rate. Two, the combustion efficiency. And three, the smoke production. Let us say out of these, the flame spread rate refers to how quickly the flame propagates. Across the surface. Faster the speed, rapid the fire growth. This escalates the danger. Combustion efficiency describes how completely the fuel is burnt. Higher efficiency means hotter, cleaner fire with lesser smoke. Lower efficiency means incomplete combustion causing toxic smoke and soot. Incomplete combustion is more dangerous. It causes toxic smoke and the thick black smoke which is called soot. Smoke production, the third factor. It impacts visibility. And survivability of people who are entrapped during fire emergencies. So, dense smoke impairs visibility and hinders evacuation processes, posing severe safety risks. One critical phenomena in fire dynamics is flashover. The most critical phenomena we can say. In fire dynamics is flashover. Flashover occurs when a compartment fire, that is a fire in an enclosed space, a compartment fire reaches the temperature threshold causing all combustible materials to ignite simultaneously. That is the danger. Okay. This rapidly spreads as a small localized fire. But remember friends, this is a fully developed fire. So, we all know a fully developed fire has got a very serious risk of mitigating or suppressing this. Suppressing such fire is a great task. In fact, it is not possible. Another dangerous phenomena which happens in industrial fire is the backdraft. This occurs under distinctly different conditions. For example, in an enclosed space, a fire may burn slowly. Can you ask me why? Because this is due to insufficient of oxygen, and this is what we call as smoldering state. When oxygen is suddenly introduced in a large quantity, by opening windows, doors, breaking window, etc., the accumulated combustible gas explodes. Okay, and that causes very severe reignition . The rapid influx of oxygen combined with these gases creates a combustive wave which is very powerful. This explosive event is termed as backdraft. And it is a very significant hazard in firefighting. So, therefore, friends, understanding this phenomena becomes important. Let us look at what are the fire vulnerability factors which affects this, applicable to maritime structures. We will pay attention to maritime structures. If we talk about this, I will in fact go to a subset saying offshore topside of the platforms. The key vulnerability includes various factors. Let us see what are those factors. The key vulnerability includes various factors. The module arrangement given in the structural system, the electrical equipment present in the system, the presence of quantity and rate of flux of growth of hydrocarbon, any other flammable material present in this, possibility of gas releases happens in the system, operations involving heat and process equipment failure. Above all put together, if there is a human error added to it, then fire vulnerability is very, very high, friends. So, one can say various factors quickly listed are: 1, of course, the presence of hydrocarbons, which is in abundant in offshore platforms. As I said, hydrocarbons, when they burn, they can reach a very high temperature as high as 1200 degrees Celsius within minutes of ignition. Very quickly, they can reach such high temperature. Secondly, the presence of electrical equipment. Electrical faults such as short circuits, equipment malfunction, continuous sparks can all result in this kind of fire accidents. Failure of process equipments can also result in this kind of accidents, such as compressors, pumps, separators can all fail. They lead to overpressure situations. They lead to overpressure, which can cause accidents. Furthermore, friends, operations involving heat processes which are exothermal, such as welding, cutting, what we call flame cutting, grinding. Okay, these are operations which involves extensive heat. They can also pose risk of fire and explosion. Furthermore, friends, gas release in an uncontrolled manner can also result in explosion. Of course, nevertheless, human error in wrong operations, bypassing safety operational procedures can also result in fire and explosion. If you have stock of other flammable materials, such as chemicals, lubricants, they also increase the potential of fire risk. Most importantly, friends, coming to the design, the module arrangement, such as configuration of top side, vertical and horizontal zoning, so they can be a big issue compared to designing the system for firefighting. So, friends, in summary, in this lecture, we learnt about fire and explosion characteristics. What are the factors that can cause fire? Amongst the fire category of industrial fire, how they can occur, how they are vulnerable. We can discuss, and we have discussed them in detail in this lecture. We will take it forward to further understand the fire scenarios, most common scenarios such as cellulose fire, hydrocarbon pool fire, etc. What are their causes and consequences, how they can be controlled and suppressed in the design perspective. We will see them in the coming lectures. Thank you very much. Namaste.